Critical angle is going to be refraction, which means we are looking at Snell's law. As we know, Snell's law, n1 sine theta 1 equals n2 sine theta 2. I'm just going to give that a quick rearrange. I'm going to say that n1 over n2 equals sine theta 2 over sine theta 1. When we're looking at critical angle, it's really important that n1 is greater than n2. The reason for that we'll look into once we've derived our equation. So, we'll look at three quick situations. We're going to have refracted ray coming in. Because we know n1 is greater than n2, it's going to refract away from the normal. So, angle of incidence is going to be smaller than angle of refraction. What we're going to do, we're just going to look at three situations where we increase our angle of incidence. So, as we start increasing our angle of incidence, our angle of refraction will increase, like so, until eventually we get to a point where our angle of refraction is at 90 degrees. And this is the point where we've reached our critical angle. So by definition, a critical angle is the angle of incidence that produces an angle of refraction of 90 degrees. The key thing with critical angle is that it is a property of a boundary. So it is dependent on both materials. It's not a property of a single material, it's dependent on material of incidence and the material of refraction. And if you change one of those materials, you will change the critical angle. So by definition, critical angle has got an angle of refraction of 90 degrees. That means in our equation up here, this sine theta 2, sine of 90 degrees, is just going to be 1. So sine theta 2 equals 1. That means that equation boils down to n1 over n2 equals 1 over sine theta. And this sine theta 1, as we said, is our critical angle, so we're just going to call it sine theta c. We can actually simplify that even more if we know that n2 is air. So if we've got a material and we're passing out into the air, we can approximate refractive index of air to be 1, which means this equation will simplify down to m1 equals 1 over sine of the critical angle. Earlier on we made the assumption that n1 has to be greater than n2. The reason for this is based on this equation here. Sine theta is, in this situation, always going to be less than 1. That means 1 over sine theta must be a value greater than 1. In order to get a value greater than 1 on this side, n1 must be larger than n2. If it's not the case, then we can't get a critical angle.